just going to make a quick video for you, just talking a little bit about arcs and sectors. As you know, we're doing the revision of the 2D shapes at the moment, and this is something you may or may not have done in grade 6. So I'm just going to go through a couple of examples and just summarise the formulae you're going to need for this, and hopefully that will help you to try some of the questions that involve arcs and sectors. So first thing we should do is probably make sure that we know exactly what an arc and a sector is. So first things first, an arc is like a little bit of the top or around the edge of a circle. You can see on the little picture there that I've shown you in blue what the arc and sector is, that little bit there. So it's like, imagine if you have a whole circle all the way around, you're just taking out a little section. A sector is like an area. It's like if you have, imagine that circle is like a pizza or a cake, and you're taking just a slice, you're saying how much is the slice. The final thing is you'll see a lot of this little symbol here. Okay, this symbol here represents the angle, and obviously that can change depending on how big you make the slice. But we call this theta or theta, depending on how you pronounce it. It's like a little Greek letter. So this represents an angle. Okay, so how big is the angle? Is it 10 degrees, 20 degrees, and so on? So theta represents an angle. Bigger the angle, bigger the slice. Now the fourth thing you might want to just be careful of is when people talk about perimeter. Now, perimeter of a sector is different to the arc. The arc is just the curvy bit, okay? Whereas the perimeter is all the way around. So it's those two straight lines at the bottom, okay? So we've got this straight line here and here, okay? And it's also the arc at the top. Imagine you're a little person stood here at A. It's saying how far would you have to run if you went all the way around and back to the beginning. So that's arcs, sectors, perimeters, and theta. So if you hear me talking about theta, it means the angle in the middle, just so you don't think I'm just making words up. So let's do a quick question together. Now let's imagine you had a question like this, and it asks you for the length of the arc, so that's AB, so that's the curvy bit at the top. It also wants to know the area of the sector, so that's, we coloured it in better, this here, AOB, because it's between A and O and B. The first thing that might be helpful for us to know is the whole circle. So let's just do a quick recap. Obviously you have been practicing this a lot. So let's say we did the area of the whole circle. So first thing we need to do is do our formula, pi radius squared. So we do pi times the radius, which is 5, so 5 squared, and it's going to be 25 pi. I'm going to leave my answer in terms of pi. I'm not going to change it into a decimal. If you get in the habit of doing this, this is how your answer should be given to you on your calculator if you're using the standard green one at school. And if you get into the habit of leaving it like this, in a minute you're going to see why it's going to make your life a little bit easier. We could also do the circumference. That's the whole way around, the whole circle. That would be 2 times pi times the radius. That's 2 times pi times 5, so that's going to be 10 pi. So if I wanted to know the area of the whole thing, 25 pi, and the circumference is around the edge, 10 pi, 2 times 5. And we're going to leave them in terms of pi to help us. Okay, so now we're going to try and do just the length of the arc. So we look at this section we have. So the arc, we know, is one section of the circle. It's like a fraction of the circle. It's a small part of the whole. We know if we take the whole circle, it's 360 degrees all the way around. But we don't have 360 degrees here. We only have 60 degrees. But we have 60 degrees out of the total, out of 360 degrees altogether. So we can write the size of the sector and the arc as a fraction. Now if you type in 60 over 360 onto your calculator, this is a calculator unit, remember, it will simplify it and say, well, it's 1 over 6. So that tells you that this slice is exactly 1/6. If you cut up the shape into slices, then it would make exactly 6 slices. That's not how they're going to look, but you get the idea. So we're going to get something like this, I think. Yeah, so it's going to be something like that. 6 exact slices. Again, I haven't drawn it perfectly, but you get the basic idea. So we know that the arc is 1/6 of the total. Well, the total we already know because we just worked it out. We said the circumference is 10 pi. So we know that therefore this must be 1/6 of that 10 pi. Literally, I take the whole circle, 10 pi, and I cut it in 6. And when you type that into your calculator, it will give you something that looks like this. And if you want to leave your answer like that, that's absolutely fine. But some of you may not be comfortable with that, so if you were to type that in, 1/6 times 10 pi, it will give you that as a fraction. It would also give you 5.24 centimeters as a decimal. But the best answer you can give is this one here. Okay, as soon as we start doing a decimal, we have to start rounding, and then it gets less and less accurate. If we just leave it in that version there as a fraction, it's the best form. Even better than that, if you were going to be even more advanced, is you could say, well, 10/6 is 5/3. So you could simplify the fraction even further. So, to summarize, an arc, you do exactly the same as a normal circle. That was this here, but we just work out a fraction. I wonder what's going to happen for the sector. Remember, we were doing the area of a sector. So again, we know we have 1/6 of the whole circle because we did the angle divided by the total. We know that the whole thing was 25 pi. And we type that into the calculator, and it gives us 25/6. And that's your answer. And you can leave it like that. You don't need to do anything to that. But if you did want to write it as a decimal, you can do that on the calculator, and that will give you 13.1 centimeters squared. But it's better, if you can, to leave it in terms of pi. So, whole circle is 360 degrees. How much of the circle do you have? You put the angle on the top, you put 360 degrees on the bottom, and then you simplify it if you can. Sometimes you won't be able to, and then you multiply that number. Just as a quick extra point here, if we left it as 60/360 and we hadn't simplified it, we still would have got the same answer. So you don't need to simplify unless you're doing it at the end. Okay, so to summarize, we should end up with something like this. And you can see we're using that formula, which is the angle over 360 degrees. You'll sometimes see this written as this. And I'm going to show you where that comes from in a second. Okay, so just remember what fraction of the circle do you have, and then you multiply that by the whole amount. Now let's imagine we were given a question like this where we don't know the angle or the length. Well, we know the angle is here, that's the angle, and this is the radius. So again, we can work out the whole circle. It's going to be area, pi r squared, and the circumference is 2 pi r. But we want to work out the arc length. Well, again, I need to work out how much of the circle that I have. And I can't work out an exact fraction because I don't know how big the angle is. But what you can do is say, well, I know that I've got the angle is a slice of 360 degrees. So I can use that formula, and I'm going to multiply it by the length, because I know that I've got this much, this fraction of the total. It's the fraction of the total. We can apply the same logic for the area of the sector. I have this fraction of the total. So every time you see an arc and a sector, you just think, I've got a fraction of a circle. What fraction is it going to be? And you find that out using this formula, because you know every circle is 360 degrees, and that little oval with the line in between, theta, tells you what size that angle is. So that is just this bit here. And that's it. There is no extra bit, so I'm just going to finish off by just writing down the final formula for you, okay, and just pointing out one last thing. So we also can talk about the perimeter of a sector. So the perimeter of a sector, like we said at the beginning, is all the way around. Yeah, the arc is just the curvy bit. So when you do the perimeter, you're adding on the straight lines. So the straight lines, each one is a radius, so it's two of them. You add on two radiuses. So you work out what's the curvy bit, which is this bit here, and then you add on two radii to the end. So obviously you can pause this video if you want to write down those formulae. They're also on the notes that I gave you and on the My IMS lesson. For those of you who struggled with this last lesson, if you finished the first few things like circles and trapezium stuff, this would be the next thing to try. I've also put a couple of practice activities on the Teamy post for you to try today. So give this a go, use the formula to help you, and just remember, an arc and a sector are just a fraction of a whole, just like a slice of cake is a fraction of the total. Okay, give it a go, and I'll be here on the Google Meet to help you if you need.